So in this video, I'm going to give a conceptual proof of the Pythagoras theorem. There are actually many proofs. There's in excess of 500 proofs. I've just picked this one. It's called by intersection, and it's easy to visualize, and I like it personally. So we'll start with the theorem first, which is that if you have any right triangle, which means one of these angles is 90 degrees, and if the three sides are of length A, B, and C here is called the hypotenuse, the side that's opposite 90 degrees. Then if we create squares that correspond to the lengths of these three sides, the way I've drawn in this figure, then the sum of the area of these two squares is exactly equal to the area that corresponds to the length of the hypotenuse. And in algebraic terms, that means a squared plus b squared equal to c squared. And that's true for any right triangle. So to start the proof, we'll start with the two squares that corresponded to those sides, and I'll call these the dimensions. This is b by b, and the other one is a by a square. So the key step for this particular proof is to draw two lines that will give you that right triangle. So what I'm going to do is to mark the length here. This is A. And if I draw this line, then that's my right triangle that I started with. Because if this is AB, the hypotenuse is C. That's 90 degrees here. And if I connect this point to that corner of that square, what about this triangle? So we know that this entire length is B plus A. We notice B and A. So if I have A here, then this remaining length has to be B. So again, we create the identical right triangle on this side as well. That's C as well. You can do it this way, or the other way would be if this is A and this length is B, then this piece would be B minus A. And if I add A to it, which is from this point to that would again give me B. So that's the first step. And the question is, how can we rearrange these pieces? So before I go there, I just want to show you a summary of what those two lines would look like. The key is we're at this step, and how do we rearrange these pieces so that we can show that the sum of the area of these two squares is equal to area of a square that corresponds to the dimension that is of the hypotenuse. So at this moment, you can pause the video and think about how to rearrange this these pieces here, but I'll continue with the solution. So one more thing I want to do actually before I go there is this dimension here. And if we look at this figure, this is B and that's A, which means that this protrusion would be the difference between B and A, and that's B minus A. And you'll see we'll use that as well. So that's B minus A. That's B. And then we have, this is A. And that's B. And this is A. So what we're going to do is to move these pieces around. And that's kind of the motivation. So we've kind of split out these two triangles. And what we're going to do is to rearrange them. And the idea is we're going to take this piece and move it here, something like this. And we're going to take this piece and move it there. So basically we translate both of these. I'll show you in the next figure, which just reiterates the dimensions. So we've just kind of moved those pieces over, and what you'll find that we form this four-sided figure. So here I've intentionally shown them a little bit apart, but if you merge them, you'll form this shape. The first thing is that these are all hypotenuse. Now the question is it a square, and do these points meet here? And that's kind of what I want to go over here. So if I take this piece and place it there, because we have to make sure that they do indeed meet at this point. So that's B here to here. And this distance that it sticks out from that corner would be the difference between b and b minus a, which is just a. So that is a. And if I take this triangle, this side is of length a, so that's going to fit in perfectly here, and that's b. So yes, it will indeed fit in here. So the way I've shown the figure is indeed how they would merge. Now the other question is, all four sides are equal. Is it a square? Meaning, are these angles 90 degrees? And the reason for that is that when we started with this any right triangle, this angle is 90 degrees, which means the sum of the other two angles is 90 degrees. And here, it's these two angles that merge at every corner. So they are equal to 90 degrees here as well, because the two angles are here on this side, which means the remaining has to be 90 as well. So we do indeed have a square with sides C, C, C. So if I had to summarize the result, we started with these two squares, dimensions B and A. We ended up with a square of side C, and these were all sides of any arbitrary right triangle. And what we've shown is that a square plus b square is equal to c square, which is the Pythagoras theorem.